Hello everyone, my name is Shravani Patil and I am from Vellore Institute of Technology. I am from the Computer Science and Engineering branch. As a member of our prestigious chapter, IEEE Computer Society, I am going to take a seminar on Node.js today. This session is a part of our TechNiche event. Let's see what Node.js basically is. Node.js is a runtime environment for executing JavaScript code. We use Node to build backend services, also called as APIs. API, as the full form says, Application Program Interface. Application Program Interface are services that power client applications like web applications and mobile applications. Web applications and mobile applications have two portions, the front end and the back end. Node.js is the thing that helps in the back-end part of developing. Node is ideal for highly scalable, data-intensive, and real-time applications. There are many other tools like Django, ASP.NET, etc. So why do we use Node? Node is great for prototyping and agile development. It has a super fast and highly scalability. JavaScript Everywhere is used in front end and back end. So the transition is easier for the developer to transition from front end to back end. Node is used in production by companies like Netflix, PayPal, Uber, Walmart, etc. Because JavaScript is used in the front end and the back end, we get a more cleaner and consistent code base. Lastly, Node has a large ecosystem of open source libraries. Now let's understand what basically runtime environment is. Before Node, JavaScript was used only to build and run inside our browsers. Every browser has a JavaScript engine. A JavaScript engine takes a JavaScript code and converts it into machine code that our computer can understand. There are many JavaScript engines that are used by browsers. Internet Explorer uses Chakra, Mozilla Firefox uses SpiderMonkey, Chrome uses V8. The V8 JavaScript engine is one of the most powerful JavaScript engines out there. Up to 2009, JavaScript could only be run in browsers. In 2009, the creator of Node, Ryan Dahl, took Google's V8 engine and embedded it into a CPP program, and therefore the birth of Node has taken place. Now Node became a runtime environment and it has all the benefits the browsers could have provided and also some objects that the browsing couldn't provide. Node can now be said as an addition of a V8 engine and the additional capabilities that cannot be availed on the browser. Let me make this very clear. Node is not a programming language. Therefore, we cannot compare programming languages like C or C++ with Node. Node is also not a framework. We cannot also compare it with frameworks like Node is basically a runtime environment for executing JavaScript code. Let me tell you how Node basically works. Node has a non-blocking or asynchronous architecture. Asynchronous architecture means it does not block further execution while one or more operations are in progress. In simple terms, this means that multiple related operations can concurrently run without waiting for other tasks to complete. Let me explain this by giving you a restaurant example. In a restaurant, when you go to a restaurant, a waiter is allocated to you. He takes your order and goes to the kitchen to give the chef to prepare the order. Now, the waiter does not wait there for your order to get completed, right? He in the process of completing your order, while the chef is preparing your order, the waiter goes and takes order from another table. This is an example of asynchronous architecture. When the waiter is not waiting for the whole order of yours to get completed, while your order is being prepared, to save time, he goes to another table and gets another order. And then when your order is completed, he serves that order to you. Here, the waiter is like a single thread allocated to handle a request. So, a single thread is used to access multiple requests. In contrast to blocking to non-blocking or asynchronous architecture, we have synchronous nature that exists. Synchronous is a blocking architecture and is best for programming reactive systems. While one operation is being performed, other operation instructions are blocked. The completion of the first task triggers the next, and so on. Taking the same example of the restaurant, we can say that when a waiter comes to your table and takes your order, he now goes to the kitchen, and gives the chef your order. He will wait there until and unless your order is prepared. This is called a synchronous type of architecture. Till your order is being prepared, he does not go to any other table to get or take their order. He finishes, when the chef finishes your order, he brings that order to you, he delivers it to you, and then moves on to another table. This is called as synchronous nature. Node applications are asynchronous in nature by default. Here, in synchronous nature, multiple threads are used to handle multiple requests. Node applications are synchronous by default. This architecture makes Node ideal for input-output intensive applications. We should not use Node for CPU-intensive applications. Now, enough of the theoretical things. Let's get to the practical things. Let's install Node. Let's first check if Node is installed into your computer system. You can go to the command prompt or your terminal and type the command node space -- version. Let me just demonstrate that for you. Node -- version. I have the Node pre-installed in my computer system, as you can see. If you do not have Node installed in your system, you can go to this website and download the LTS version. Let me just demonstrate that for you. I went to this website, nodejs.org/en, and then download this version, the LTS version. You can either download the current version, but the LTS version is a much stabilized form of the current version. It's a different version, but it is much more stabilized. This is recommended for most users. You can click on that and download it, and then you can install it. Now, again, to check if it is being installed into your computer system, if it is being installed into your computer system, you can go to your terminal and write node space -- version. Yeah, I have installed the current version, but I would recommend to install the LTS version. Let's get to writing our first Node program. Let me first make a directory . I have made a directory called NODE.js . Now, I will open this in my VS Code. I will open this folder, this directory in my VS Code. I will make a new file called app.js . Yeah, really sorry for the technical issue. Firstly, I have made a file called app.js. In this file, we are going to write our first I'm going to write our first Node program. I'm creating a variable called XYZ . I have created a variable string called XYZ. Now, I'm going to create a function in JavaScript called ABC, which accepts a parameter name . To display that name parameter, I've used the function console.log. Now, I'll call this function. For executing this Node program, we will use the terminal. You can access the terminal by using the above bar terminal and then clicking on the new terminal. For running this program, the command used would be node space the name of the application, the name of the file. See, we have written a JavaScript program and made it run in our own terminal. Before 2009, this was not possible. We had to run the JavaScript program in our browsers. Now we've written our first Node program. Let me explain you what modules are. Module in Node.js is a simple or complex functionality organized in single or multiple JavaScript files, which can be used throughout the JavaScript application, which means that you can make a module and then use it in other different files. Modules that we will learn and that are built in the core of Node are path module, OS module, that is the operating system module, the file system module, the HTTP module, and we will also learn how to create our own module. Firstly, let me give you a glance on what global objects are. Global objects are objects that can be accessed from anywhere in the system. Here, we can see some of the examples of global objects are console.log, another example can be set timeout. We use this to call a function after a specific amount of delay, like 2 seconds delay or 5 seconds delay, whatever. That I just gave an example. Or functions like clear timeout are also examples of global objects. Set interval is also an example for global object, and many more others, but these are the certain amounts. These are the certain amount of objects that I would be defining, that I would be making you aware of. And clear interval. These are some of the examples of global objects. Now, let's learn how to create a module. Firstly, I'm going to make a file, another file, which we would call as a module. We can call every file as a module here. Each file is said to be a module. Let's add a new file to this application. We name the file as display.js. Right? I am creating this function that would display anything that you want, and we'll access this display.js in our app.js module file. Display.js module in our app.js module. Yeah. Let me create a function that would display a message. So let me name the function as disp, which takes the parameter of a message and we will display that message using console.log message. Now we have here created a function that would display our messages. How do we export this to our other file? We use the function, we use the object, we use the module object here. Module, which has a property called exports, which we can give a method that we would use in our other file. That would be DISP, which equals to this function. Yeah. We can name this display differently. We can use any name here. We don't have to use the same name. So let me show you an example. This PN. Yeah. This is how you would export these modules to other files. This is an example of exporting a function. I'll show you how to export another variable or a string that you can see. Variable, I created a variable named message, which would say hello PIT. Yeah. I would export this using the same procedure. I would export this message also, which is a variable string, which is a string variable stored in the name of message. You can use any other name. Let me just. Okay. Yeah. I'll use the same method to export this as used before. Name equals to name. Just for the sake of simplicity, I'm using the same names that I've called. It would be easier for me to access here. This is how you create a module. Now let's see how to load a module into this different file. We use the function require to load this module. So you would say require and then type in the file's name. .js. You can either omit the .js as this thing is intelligent enough. So you can either write .js or you can omit it. Now here, as we know that both the files or both the modules are stored under the same folder. What we would do if they were stored under different folder, we would use the syntax of dot slash, and then you could have chosen the folder in which you could have used in which the other module has been stored and then written. But right now we have it under the same folder, so dot display. Now this require function returns the exported items from the other module. The other module, which is the display module. Here the exported items are DISP, disp, and name. Now we will store this into a variable or into a display equals to require display. Let's see what this display means. I will now run the node app.js. Sorry. See, this display function gives us two objects called DISP and name, The first object has a function inside it, and the other object has a string called name inside it, which says hello world. Oh, sorry, hello VIT. So using this display, we can access those objects. Let me comment this out. We use the command plus slash shortcut to comment out. In Windows, we use the control plus slash forward slash shortcut. Now let me access these objects from the other module. I'll store these objects into a constant, which I would name display, which I would equal to display.disp. As this is a function, we would have to pass parameters. So I'll pass this parameter in this function, disp function. So I'll take another variable called name, which equals to display.name, and then I'll pass this name as a parameter in this function. And I'll console.log this function. No. Yeah, I'll make this function run. See, we got the message hello VIT. We use this by creating another module of our own and then using it into this file. As we know that there are many modules that have given a brief of earlier, given the titles of earlier. So let's learn what these modules give us as a function. Let's go to this NODE.js.org website and then click on the docs section. We would click on our LTS version, and then there are some embedded modules that already exist in Node. We can work with these files, network, and so on. Now we can see the built-in modules. Of course, not everything here is a module, like the console object or the buffer function, which we would use afterwards. For our modules, we have file system, HTTP file system, OS module, which is the operating system module, the path module. Now let's look at the path module. There are many other functions that are provided here. We will use the parse function. We have to export this path module, but as this is a built-in module in our node, we can export this using just require and by mentioning the name path. This is a built-in module, so we don't have to mention the dot slash and everything for it. So here I have taken this path object which has a parse function in which I have given the file name as parameter. The file name is this name, app.js, the current file name. Let me store this into a constant named as path obj. Let me show you by console logging the path obj. Console obj. I'll run this file. Oh, sorry. Path obj. Run this file. This has many properties like root, directory, base, extension, name. The directory one gives us the path from which we can access this file. The base is the name of the file with the extension. Extension is the extension that we've used here, JS. And name is the name of the file, the app name of the file. Now, using these properties, we can see what the see, we got the base, dir, ext, name, root, name. Here. And comment this line out. The base is same as the base here, and then we got the result as avp.js. We're done here with the path module. There are many other functions that you can use, functions, the method that you can use, but I have here used only the parse function because we have a limited time. So yeah, now let's get on to the OS module. The OS module helps us to get the information about the current operating system. Let's go to the node documentation. We have our OS module here. These are the functions that we can use in the OS from the OS module. We quickly show you the free mem function. This function returns the amount of free system memory in bytes as an integer. Yeah. Let's just use that. Firstly, as our root, we use const os. We have to import that module. Require os. Now that we've imported that module, we use its functions. Equals to os dot free mem. This function gives us the amount of free space that is there in your operating system. I'll display that using console.log. Let's run the see, this is the amount of free memory in bytes as integers in your operating system. There are similar other functions that you can use, like total memory, and let's display that also. So yeah, this total memory function tells us how much memory that has been allocated, that has been there initially in your operating system, which is much more greater than the free memory right now. Yeah. Other functions also include home dir. This returns the string path of the current user's home directory. I'll give you a demonstration of that. Let's display the home dir method. I'll comment this line out so that we have a clarity of our function that we're using. So this is our home directory. This is the path to our home directory. Other functions also include the OS type. The OS type function returns the operating system name as returned by union. For example, it returns Linux for Linux, Darwin for Mac OS, and Windows _NT on Windows. Now, as I'm using Mac OS, it should ideally return Darwin. Let's get a demonstration of the same. Let us display that. See, I got the result as Darwin, as I am now working on a Mac OS operating system. Yeah. Now, as we have looked onto our OS module, let's further get into our file system module. This is a very important module that is used furthermore. Let me show you the documentation of the file system module. Yeah. This is the documentation of our file system module. We will be demonstrating the readdir function right now. So, as we know, for importing a module, we use require function file system. Yeah. Now, file system dot and store this readdir sync into a variable or a constant. Let's use a constant here. Equals to, and I'll display that function, this thing, using console.log. So this returns two files that are present right now in this directory. I used // here. We can also read files from other directories by using .. Let me just demonstrate that for you. .. let's see, Java. This is a folder on my system. The and just run this. See, these are the files that are there in that folder. So yeah. As we've seen the file system module, let's look at the HTTP module as well. This is one of our last modules that we're going to look at. Let's go to the documentation part of it, HTTP. There are n number of this thing functions that can be used, functions or classes that can be used in the HTTP module. We would be using the create server and the listen functions or this thing for our demonstration today. Let's import the module first. Import constant HTTP equals to require. We again and again, I'm going to repeat that we import the module using the require. Function. Yeah. Now let's create a server that would listen to a request and get the result. So for doing that, we would create a constant which we would name it server, which would equal to HTTP dot create server. This create server accepts a callback function which would see the listen request listener is a function which is automatically added to the request event. So we will have a callback. We will write a callback function here, which would be request, which would have two parameters, request and result. This is another way of writing a function in JavaScript. You can write it this way also. So res.parent. The message that we have to write here. Let's write hello world. And then we have to end the result. So we use result.end. Yeah. Now that we've created a server, we would have to listen to that server. So we would write server dot listen, and use the listen function. Let's write a port number where we say 7100, and then console log a message. Console.log listening to the port 7100. Let's run this node app.js. As this is listening to the port 7100, let's open that in our tab by using localhost. Localhost 7100. See, we've written a message, hello world, using this create server. Now that we've reached to the end of our HTTP module, I would thank you for listening to my lecture, and I hope I made a difference in your web development journey. Thank you so much.